everyone. So now that we feel a little more comfortable with linear equations and how to graph linear equations, we are going to talk about linear models. So let's just refresh. Linear refers to an equation or function that is a straight line when graphed and takes the form y equals mx plus b, where m is equal to the slope and b is equal to the y-intercept. Because it's linear, it has a constant rate of change through the whole line. So that means there are equal differences over equal intervals. Just like when we looked at the slope formula, it has to be equal the entire way. The exponent is always 1 in a linear expression. So if we look at this example, y equals 2x plus 5, we know that there's a little invisible 1 there. So that makes this linear. If that exponent was higher than 1, it is no longer linear. Okay, so a linear model is a linear equation that represents a real-world scenario. So here we have an example. Deanna is a cashier at a local supermarket. She automatically gets paid $10 when she comes in and an additional $8 an hour for her work. So here, this is a word problem that represents a linear situation. If we were to write this equation, it would be y equals 8x plus 10. She gets paid $10 and then $8 for every hour. So today we're going to look at how we go from a word problem to an equation. Before we do that, we need to know some definitions and some words that we're going to be using in this lesson, and we need to know the ins and outs of everything. So the first one is dependent variable. Hopefully that sounds familiar. We did talk about that when we talked about functions. The dependent variable is usually the y variable. It changes in response to the independent variable. Most of the time, a dependent variable will be money, but that's not all the time. So in most scenarios, it will be, but every scenario is different. We're not always going to be talking about money in word problems. It just does show up a lot, so I want you to keep that in mind. But when you think about money, money usually depends on something else, like how many hours you work depends on how much money you make that day. How many months you've saved for depends on how much money is in your savings. So that's why money is usually dependent on something else in these scenarios. We also have independent variable. So this changes by itself. It does not depend on anything. A lot of the time, this is usually time in the scenarios that we're looking at. Time will keep moving forward. It doesn't depend on anything. And things usually depend on time. So like I said, the amount of money depends on how many hours you worked, how many weeks you saved, how many days passed depends on how much you're growing, something like that. So a dependent variable is something that changes on its own. Okay, a constant is a fixed number that doesn't change. A constant is it's also a number that doesn't have a variable next to it. If you have a number that has a variable next to it, that means that can change based on whatever that variable is equal to. A constant is a fixed rate. It's also the y-intercept, and it's going to be a starting point for these scenarios. Then we have rate of change, how much something changes over time, and that is the slope. So remember, slope and rate of change mean the same thing. So for example, if you make $8 an hour like Deanna did, that is a rate of change because you make $8 the first hour, then you make $16 for the second. So you add 8 each time. So that changes based on how many hours you work. The constant, that $10, just to go back to that slide, this $10, she automatically gets paid even if she doesn't, as long as she comes in. So she can work 2 hours, doesn't matter, she'll still at least get $10. Okay, so that's important to keep in mind. So when we write these linear equations, our dependent variable is equal to the rate of change times the independent variable plus whatever that constant fixed rate is. And that's where y equals mx plus b comes from. That's why we're able to graph these situations like straight lines, because it is a linear situation. Okay, so let's take a look at a word problem and let's write it as an equation. Okay, a cell phone salesperson earns a base salary of $40,000 plus a commission of $300 for every cell phone she sells. Write an equation that shows the total amount of income I that salesperson earns if she sells C cell phones in a year. Okay, so I'm going to treat this like English class for a minute. I'm going to annotate what I think is important. So she earns a base salary of $40,000. So what that is saying that is that no matter what, she's going to make $40,000 whether she sells 0 cell phones or not. That's going to be the smallest amount that she can make this year. That's not going to change. Okay, plus a commission of $300 for every cell phone she sells. So it's $300 per cell phone. So just to shed some light on what a commission is say she sells a $1,000 phone, she's going to get $300 from that. Commission is a percentage that you can get from each sale. So in sales, a lot of people work off commissions. Okay, but that's not every job. This person does. So $300 for every cell phone that she sells. We want to write an equation that shows the total amount of income I. So the income is going to be I. Income is how much money she's going to make. And then how much money she's going to make if she sells C cell phones. So it's literally telling us what variables we want to use here. So we have to use those variables. If they don't tell you, then you can use your own. But if they do tell you, make sure to use their variables. Okay. So now let's talk about dependent and independent variable. So the word variable is here. So we know that these are going to be letters. They're going to be variables. These will never be number values because we don't know what her income is and because we don't know how many cell phones she sold. So these are going to be letters. Okay, so now let's think. We have income and cell phones. So which one depends on which? Does her income depend on how many cell phones she sells, or do how many cell phones she sells depend on her income? So really think about it. What would depend on what? Hopefully you're thinking, and say, oh, okay, her income is going to depend on how many cell phones she sells. If she sells 0 cell phones, that's not going to be as much as if she sells 100 cell phones. So based on how many cell phones she sells, that's going to tell us how much she's going to make. So her dependent variable is I, and I'm going to write I. That's her income. Okay. Now the independent variable is the amount of cell phones she sells because that's what's going to tell us what her income is. So independent variable is C, and I'm going to write number of cell phones sold. Remember, this is not the cost of a cell phone. It's the number of cell phones sold. Let me just make that look a little neater. Cell phones sold. Okay. So now that we have our variables out of the way, we're going to take a look at our constants. So, not our constants, but our numbers. We're going to start with the constant though. So the constant is a fixed number that doesn't change. So if we look at this question, this word problem, which value is not going to change whether she sells 0 cell phones or 100? It's that base salary of $40,000. No matter what, she's going to make that base salary, and then whatever she makes other than that 40,000 is just added to it. So our constant here is 40,000. And that leaves our rate of change, which is 300. So it's 300 per cell phone. So she gets $300 for the first one. Then for the second one, it's going to be 600. It's going to keep adding 900. So that number can change based on how many cell phones she sells. So this is going to be 300. So notice we have 2 numbers here, 2 variables here. Very important. Now make sure you know where these are going to go. You can always refer back to this slide. It tells us dependent, rate of change, independent, constant, and it makes sense when you put everything together. So our dependent variable is I, so our income is equal to the rate of change times the independent variable, so 300 times however many cell phones she sells, plus that base salary of $40,000. Okay, so we're going to add $40,000 to 300 times however many cell phones she sells. That equals our income. Now, these can also be switched around. It could be 40,000 plus 300C. Addition is commutative, so we can move those around. But this is how we would set it up. Okay, So let's look at a question where they give us the equation and we got to try to figure out what's what. Okay. So Aaliyah signed up for a streaming music service where there's a fixed cost for a monthly membership and a cost per song downloaded. Her total cost per month is given by the equation C equals 25 cents X plus $2.99, where X represents the number of songs she downloads and C represents the total cost in dollars and cents. What could the number 0.25 represent in this equation? And I did say 25 cents, but 0.25. Okay, so let's just highlight some information here. So streaming music service, there's a fixed cost for the month. So no matter what, she has to pay that amount per month, and a cost per song. Okay, so those are our two things, our two numbers here, a fixed cost and a cost per song. We know that C is going to represent the total cost for the month, and X represents the number of songs she's downloaded. They tell us that in the question. So we want to know what this 0.25 is. So hopefully you look at the equation and think about what we talked about with constants and rate of change. The constant is that fixed rate, and remember, it does not have a variable next to it. So our constant here, and I'm going to just rewrite this just so I can piece it out a little bit so you can see what I'm talking about. Okay, so we know that this $2.99 is our constant. That's our fixed rate. That's not going to change. So that is going to be the fixed cost for the month. Okay. So we also have this 0.25 here, and that, because it's right next to our variable, we know that's our rate of change. So we know it's 0.25 times X, the number of songs downloaded. So it's 25 cents per song. That's our rate of change. It's the cost per song, because this goes with this, and then this fixed cost for the month goes with this. So we know that this 25 cents is the cost per song. So let's take a look at what answer that would be here. So the total cost per month, assuming one song is downloaded, no. That means that is our C value. That's not our total cost, that 0.25. The cost to download 100 songs. Here, we haven't plugged in any numbers. We don't know how much it would be for 100 songs. So no, it's not going to be this one. The base cost of the streaming service per month. We know that the base cost is this $2.99 because it only happens one time. It's that constant. So we know that it's not the base cost. So it's how much the streaming service charges per downloaded song. Cost per song, 25 cents. 25 cents times however many songs she has, plus that $2.99 equals that cost. So hopefully when we break it down, it makes it a little easier to see how we can figure out what's what. All right, let's look at one more example. Okay, an elevator travels down from the top floor of a skyscraper. Its height in feet is given by the equation h equals 500 minus 32t, where h represents the elevator's height in feet, and t represents the time in seconds. What could the number 500 represent in this equation? So first, we're talking about a skyscraper, so I'm going to just do this little drawing here. So here's my skyscraper, here's my elevator, and it's going downward. This is what's happening, right? And this is the equation that represents this. So we have h equals 500 minus 32t. So I want your first instinct to be identify which number does not have a variable next to it. That is your constant. So here, this 500, that's our constant. Even though it's not written at the end, that's fine. That's the number that doesn't have anything attached to it. So that means that this negative 32 is our rate of change. Okay, so let's think about what that would mean in terms of this question. We're talking about a skyscraper, and it's going down. So like I said before, a constant is the starting point. So when we think about it in terms of this skyscraper, that means the starting point, the starting height of this skyscraper is going to be 500. So constant is always that starting point. So it's going to start at 500, and then it goes down 32 feet per second because it says t represents time in seconds. So it's going to go down 32 feet per second. Okay, so that's what we know. We know that this constant, that's the starting height of our at our elevator in our skyscraper. So let's take a look what answer this would be. So it says the height of the elevator at time t equals 0. So if it's time t equals 0, that means no seconds have passed and it's still at the top, right? That's our starting point. So this is our answer, but I do want to go through the rest of them to make sure that we have canceled everything out and have looked at all the options. So this says the elevator's height after 1 second. So when you think about it, it would have gone down 32 feet after 1 second. That wouldn't be equal to 500. So this is not our answer. How long it takes for the elevator to reach the ground. So that would be whatever t is once this height is equal to 0. So that's not what 500 is. 500 is our starting point. And this says the elevator's final height. So like we said before, this is the elevator's starting height, not the final height. So we know that this is not the answer. So it's the height of the elevator at the time t equals 0, because that means that the elevator has not started to go down. So make sure you identify whenever you have these types of equations, what's the constant, what's the rate of change, and make sure you really understand what's happening in the questions. If you don't know what's happening in the questions, it's going to be really hard to think about your starting point and what's changing over time. So definitely take the time to read it, reread it if you need to, and go from there.